For decades, Apple operated on a simple, uncompromising rule: total control. They designed the chip, they wrote the software, and they locked you inside a seamless ecosystem where external dependency was viewed as a weakness. By 2026, that strategy collapsed. Apple launched the iPhone 16, backed by heavy marketing for personalized AI features that were ultimately delayed for months. Consumers sued for false advertising, and Apple was forced to pay out a $250 million class action settlement. At the exact same time, their highly publicized partnership with OpenAI was breaking down. Internal studies revealed extremely low engagement with the clunky Siri integration, while OpenAI executives began aggressively poaching Apple's top hardware engineers with massive stock packages. The final blow came from within. Former Apple design chief Jony Ive officially teamed up with OpenAI to build a rival, standalone consumer AI device directly targeting Apple's core hardware market. Between costly lawsuits, aggressive talent poaching, and broken partnerships, Apple's insular development model failed to produce a competitive intelligence platform. They were out of time, and they were forced to look outside their walls for a rescue. The solution they found was historically expensive. Apple agreed to pay roughly $1 billion every year to license a custom Gemini model from their biggest rival in the mobile market, Google. Funding this massive digital pivot required immediate physical sacrifices. Apple began quietly liquidating its legacy automotive assets, starting with a secretive 5,500-acre testing facility out in the Arizona desert. They sold the unused Project Titan testing track for $220 million to Alphabet's Waymo unit, effectively handing high-speed oval tracks and fake city courses over to feed their competitors' expanding robotaxi fleet. Scrapping a decade of electric car research to pay for cloud computing illustrates a brutal reallocation of capital. Surviving the immediate intelligence race took absolute priority over transportation. That billion-dollar licensing fee powers the complete reconstruction of Siri AI. The intelligence engine driving the new voice assistant is a custom foundation model built on 1.2 trillion parameters. Trying to process over 1 trillion parameters locally on a standard mobile phone would instantly drain the battery and overload the thermal casing. This diagram demonstrates how they solved the compute problem using a mixture of experts configuration. When you ask Siri a question, the system isolates and triggers only the specific relevant pathway of nodes required to answer that exact query. Even with that extreme efficiency trick, the processing still has to leave the phone. To execute this at the scale of millions of active users, Apple routes the requests directly to NVIDIA Blackwell B200 GPUs hosted inside Google Cloud. The mixture of experts architecture acts as the mathematical bridge. It is the only way to tap into Google-level supercomputing without destroying local hardware performance on consumer devices. Sending massive amounts of voice and text data to Google creates an enormous liability for a brand built almost entirely on the promise of user privacy. To prevent Google from accessing your data, Apple engineered this 3-tier routing stack. The lowest tier handles basic tasks using proprietary Apple silicon right on your device, zero data egress. For moderately complex requests, the middle tier takes over. Your phone connects to Apple's private cloud compute servers, running on custom hardware verified by independent security researchers. When you ask for heavy reasoning, the system pushes data to the final tier, the NVIDIA GPUs inside Google Cloud. But before it leaves Apple's infrastructure, it hits a cryptographic pipeline that strips away all personally identifiable information. The data is tokenized and entirely anonymized. The request is processed by Google's hardware, but no one can link that query back to your identity. This routing stack functions as both an engineering shield and a legal barrier. Apple legally exploits their rival's massive processing power, while ensuring the host network remains entirely blind to the customer data. Rebuilding the software ecosystem triggered the most dramatic executive shakeup at Apple in 15 years. Apple confirmed that on September 1st, 2026, Tim Cook will officially step down as CEO, transitioning to executive chairman of the board. His successor is John Ternus, a 25-year Apple veteran whose entire background is rooted in rigorous, iterative hardware engineering. You can already see his influence in the latest software rollouts. The new macOS Golden Gate and iOS 27 heavily prioritize performance stability, brutally deprecating all older Intel-based Macs to completely streamline the proprietary Apple Silicon ecosystem. Moving from Cook's logistics-heavy era to Ternus's engineering discipline marks a definitive return to the company's original identity, building vertically integrated, premium physical products. The groundwork for those physical products is already hiding in the code. Developers digging through the iOS 27 beta found specific hinge angle subroutines, measuring whether a device is closed or flat, clearing the path for an upcoming foldable iPhone, rumored to cost up to $2,400. They also released the developer preview for HomeOS, preparing the market for the HomePad, a highly anticipated smart display hub designed to anchor their connected home strategy. However, tying these premium devices to an external Google Cloud introduces massive geopolitical friction. Siri AI is entirely blocked in the European Union over digital market regulations, and Apple is currently forced to negotiate with local providers to build a separate, isolated version just for China. Authorizing this hybrid architecture cost Apple $1 billion a year and required them to swallow immense corporate pride. By outsourcing the volatile, legally fraught layer of artificial intelligence to a rival, they effectively insulated their core business. Apple ensured that its hardware remains the primary, high-margin gateway through which we access the digital world.